My name is Anna Carruthers. I'm a PhD candidate at the University of Oxford, and I'll be presenting Does Quantitative Easing Work in the Same Way Everywhere? Evidence from the COVID-19 pandemic. So, in terms of motivation, the number of countries engaged in quantitative easing since the pandemic has increased dramatically. So, before the pandemic, the only countries which used this unconventional monetary policy were advanced economies at the zero lower bound. And there weren't actually very many of them. So, turning to the map, there was the US, the UK, the ECB, Sweden, Japan, and Switzerland. So, only really 6 case studies of the policy's usage. However, what we see is that during the pandemic, QE goes global. So the number of countries engaged in quantitative easing increases dramatically from 6 to over 40. And crucially, it's the first time that emerging and low-income economies have been using this policy. They're not near the zero lower bound, and it kind of QE's usage has sort of widened to beyond its original function. Because of the recent nature of the pandemic, almost all of our knowledge and the literature about how QE works is based on these light blue economies, so these advanced economies. And so the question is, does quantitative easing work in the same way everywhere? As a spoiler, the answer is no. And then this paper thinks about what explain those differences in QE's impact and what these differences imply for where QE can be successfully used as a policy in future. So in terms of the roadmap, so where this paper is going, there are 2 key strands. So the first is there is an event study to look at QE's immediate financial market impact. So from this, we identify some key stylized facts about how QE works across different economies in our sample. And in terms of its contribution to the literature, it is the first of its kind to identify the different channels of transmission to financial markets in emerging economies. I then use these stylized facts and these financial market estimates to calibrate a structural model, which looks at QE's wider economic effects under settings when QE works through these different channels and in different ways. And this is the first in the literature that kind of does this for emerging economies and thinks about differences in channels of transmission. And finally, that kind of point 2, where the paper is going is I'm also going to strengthen the kind of stylized facts with some exogenous QE shocks. This is a work in progress, but I'll touch on where that analysis is going later in the presentation. So turning to the empirics and kind of establishing our stylized facts, for this, I use an event study approach. So what this means is that I evaluate the change in financial market variables of interest in and around central banks' announcements about QE schemes. So for this, I have a database of around 140 QE announcements, maybe 22 central banks. And this is using data from the BIS, the IMF, and also data we collected from Bloomberg News. This contains information not only on the dates of the announcements, any other kind of corresponding policy events that are happening at the same time, but we also group these announcements by type. So kind of, is it the first time that they announce a scheme? Are they saying that they're going to purchase perhaps more bonds or kind of do the scheme for longer? And we use this database to not only look at the overall movements in yields, but also test for different channels of effect and to look at the movement significance. So here we divide the changes by the standard deviation of the underlying series to say, essentially, is this a big move? And this gives us a t-statistic to assess statistical significance. So this is kind of what the maths is saying, but we look at the changes in 1, 2, and 3-day windows around the central bank announcement. And this should give us a causal identification of QE's effect under a couple of identifying assumptions, which I'll discuss on the next slide. So just to touch on the identifying assumptions briefly, I am keen to stress that in the paper, these are kind of stylized facts, and I'll talk about the empirical limitations later. But we do take some steps to ensure, well, quite a few steps to ensure validity. And in particular, we kind of think about these under 3 main headings. So broadly, event studies will identify the causal estimate of QE's kind of immediate impact on financial markets if the following assumptions hold. So the first assumption is that markets are efficient, which means that market prices will update to reflect the kind of new information that the country is engaging in asset purchases. And then to ensure this is the case, especially in emerging markets, we use multi-day event windows, so 1, 2, and 3 days, to kind of give markets time to process that information. The second is that the event is unexpected. So we need the variables of interest to not we need QE not to be anticipated so that our variables of interest don't start changing before the event window starts. To do this, I look at central bank announcement days, so the day that the policy is announced rather than the day on which the policy is kind of actually implemented, so bonds are purchased. And crucially, I use Bloomberg News to check whether these announcements were anticipated or not. So we make sure, basically check whether there is any market commentary that QE is likely to occur. There are 2 economies that have this, and the results are completely robust to excluding these from the results I'm about to show you. And finally, no confounding factors. So we need that there are no other variables affecting our variable of interest during the event window being studied. And to ensure this is the case, we use comparatively short event windows, so we don't look over kind of a week or a month. And the results are also robust to excluding QE announcements that occur alongside other domestic monetary policy changes. So, for example, a policy rate change, or other policies. So, if they the results are robust to excluding announcements that coincide with national lockdowns or kind of large fiscal policies such as kind of COVID support schemes. Finally, the results are also robust to excluding spillovers from other countries' QE or kind of policy events. So if we exclude announcements that are concurrent with US, UK, Japanese, or the ECB's monetary policy announcements, the results still stand. So those are the kind of key steps we take to ensure that the empirical estimates and all the stylized facts I'm about to show you do adequately capture QE's impact on financial markets. So what do we find? So the first finding is that emerging markets see the largest falls in sovereign bond yields, despite purchasing smaller amounts of sovereign bonds. So just to kind of clarify here, we only focus on QE schemes where governments are purchasing sovereign bonds to ensure a kind of like-for-like or apples-for-apples comparison. And what we see is, talking you through the graph, in emerging markets, so the yellow dots, countries are able to purchase a much smaller amount of bonds, so kind of the scheme is much smaller, and yet the kind of overall impact of the scheme, so the change in the sovereign bond yield, is much larger. So each dot is the kind of sum of the impact of all of the announcements a country makes about QE. And what we see is that in emerging economies, you get a lot of bang for your buck. So you can purchase a very small amount of bonds and see a really large fall in yields, compared to advanced economies who purchase much larger shares of bonds and yet see much smaller impacts. And this is particularly pronounced given the fact that each of these purchases is expressed relative to each country's GDP. So, for example, the GBR dot is UK purchases as a share of UK GDP, as opposed to Colombian purchases as a share of Colombian GDP. This result is very surprising, given our kind of current understanding of how quantitative easing works. So up until now, we thought that the main channel of transmission to financial markets was something called portfolio balance effects. What this is that when the central bank buys bonds, it increases demand for the bond in question, which pushes up the price of those bonds and lowers yields. A priori, we would therefore expect that if QE works through this channel only, we should expect that larger schemes, so kind of when you purchase more bonds, yields should fall more. The fact that we very clearly don't see this here suggests that QE is not working in the same way everywhere. And perhaps as a spoiler, there might be kind of other channels at play in these emerging markets, which can explain sort of why you can purchase less and yet get more of an impact on financial markets. The second finding is that similar types of announcements have really different effects in different countries. So, for example, leading to large falls in yields for some economies while having counterproductive effects in others. So just explaining this graph, what I've done is grouped the announcements by their type. So initial QE announcements are the first time that you announce a scheme. Follow-ups increase the amount purchased, so the number of bonds or the amount of bonds you're going to buy. Increasing your scheme breadth, so the kind of range of maturities you buy, and then we compare the impacts of those across different countries. What I've also done here is express the change in yields and standard deviations. And the dashed lines are significance thresholds. So they're at 1.96 standard deviations above and below zero. So anything outside that channel is significant at the 5% level compared to the underlying series. And what we see, especially focusing on the first three types of announcement, which we use for the rest of the analysis as they're most common, we see that the same announcement, so countries saying I'm going to do quantitative easing, has a really varied impact depending on the country. So particularly in emerging markets, we see that there are some really, really large falls in yields. So kind of, over 10 standard deviations worth of a fall. But QE can also kind of backfire and actually cause yields to significantly increase, which is going against what we want. Given that these economies are buying the same thing and announcing it in a similar way, we have to then ask or kind of infer that QE must not be working in the same way everywhere in order for us to observe these kind of heterogeneous effects. So I guess hopefully from these two slides, the key message that's coming across is no, QE does not seem to be working in the same way everywhere. So in order to explain these differences, I argue that these differences arise due to differences in the strength of QE's kind of the different transmission channels of QE's impact on financial markets. So to think about these channels in the paper, we use the following decomposition. So the decomposition is that the yield on a bond of maturity N, so here think of a 10-year bond, can be expressed as the expected path of short-term interest rates that prevail over the lifetime of the bond, and then a term premium term. And here term premium can be broken down further into factors, basically a range of factors affecting yields. So here it's liquidity premium, so kind of if you have to pay a higher yield because the market isn't very liquid and therefore you might struggle to find a buyer for your bond, any kind of credit risk or sort of default risk associated with the bond, and then relative supply or demand effects. So there might be idiosyncratic reasons why a particular bond is in high demand or perhaps in low supply, and that would increase prices and lower yields. We can then think about the change on the yield on a bond as coming from one of these four factors. And these give us our kind of four transmission channels of quantitative easing. So as already mentioned, the main channel or sort of the main game in town in advanced economies was definitely this portfolio balance channel. So the idea that central bank purchases increase the demand for bonds, causing prices to rise and yields to fall. In advanced economies, there is also a tiny bit of impact driven by the signaling channel. So this is the idea that agents update their beliefs about the expected path of short-term rates when they observe QE. So almost it's the kind of forward guidance impact of quantitative easing. And those were thought to be the only two channels sort of extant, I suppose, in advanced economies. However, there are two other channels, which are market liquidity and government default risk. So market liquidity describes any changes in yields caused by changes in the market functioning of the asset being purchased. And the government default risk describes kind of the impact that QE might have on perceptions of government solvency. These channels were thought to be non-existent in advanced economies because the markets for sovereign bonds are highly liquid and the sort of default risk is perceived to be effectively zero. However, perhaps as a spoiler, kind of in emerging markets, we might find these to be sort of slightly more important. So estimating the different asset price transmission channels. So we kind of use this framework in the paper to think about measuring, sort of empirically estimating the different channels at play in these economies. So looking at the top diagram or kind of schematic, what I've shown you so far are the overall yield changes. So the overall change in, let's say, a 10-year bond. To then get at the different channels, we do this in sort of two stages. So the first stage is that we separate the overall change in yields into a signaling effect. So the kind of effect that occurs at the short end of the bond yield. And we measure this as a change in the 1-year bond yield, which is a proxy for the risk-free rate in these countries. And then all other channels, which are captured by the change in term premium. So that's the change in the 10-year bond minus the change in the 1-year bond. And for robustness, I also look at the term premium change with 15-year and 20-year bonds. This term premium channel is a kind of bucket term, which includes portfolio balance, market liquidity, and government default risk effects. So to then separate these out even further, we proceed in two steps. Firstly, to kind of test for the statistical significance of market liquidity and government default risks. I conduct event studies on bid-ask spread, so that's a measure of the market liquidity channel, and credit default swaps, which is a measure of the kind of risk premia or the perceived default risk on a government bond. And that's to check whether these channels are statistically significant, so kind of are they present at all? And then finally, to say whether these are economically significant in terms of whether these sort of changes contribute to the overall change in yields observed. I then regress the overall change in term premia on changes in these measures and a fixed effect to assess these channels or the market liquidity and government default risk channels contribution to the whole. So firstly, thinking about sort of disaggregating the overall effect into signaling and the rest, the first thing we find is that the variation can be explained by differences in both signaling and term premia. And I suppose kind of explaining this diagram, what we have here is the change in yields, so the kind of overall impact of each scheme. The total impact is the black dots, and then we've broken this down into the impact of sort of term premia, so those long-term effects, and the signaling channel. And what we find here is that the signaling channel, while fairly small and largely insignificant in advanced economies, is large and highly significant in emerging economies. So what this means is that the change in the expected short-term rates, that channel, is much stronger in emerging economies than we previously would have expected, given our experience in advanced economies. And crucially, what we see is that the signaling channel can go in either direction. So for example, Turkey, Thailand, South Africa, Colombia all have very large negative signaling channels, which kind of compress yields. But also, if you think about the signal as being a bad sign of the economy's health, in India, actually it can kind of increase yields. So this can explain at least some of the variation we observe in kind of the overall effect, where QE seems to be having a big bite in some emerging economies while kind of backfiring in others. I think I've probably alluded to this quite heavily already, but we also see that the market liquidity channel, whilst thought to be kind of non-existent in advanced economies, is actually highly significant in emerging economies. So again, this graph has the kind of significance thresholds at sort of a 5% significance level. And what we find is that while our measure of the market liquidity channel is insignificant in advanced economies, both in those who have and haven't done QE before, it's highly significant in emerging economies. And these liquidity effects can kind of go either way. So we see kind of significant falls in the liquidity premia in Colombia, Poland, Thailand, and Turkey. And that can reflect the idea that the central bank is kind of acting as a guaranteed buyer for government bonds and almost encouraging other participants to trade in these markets. But we also see significant sort of increases in illiquidity in, for example, the Philippines and Romania. And this could be argued due to a kind of scarcity channel where the central bank has bought a large number of government bonds and therefore has kind of reduced the volume of trade available for other participants. So kind of while liquidity wasn't thought to be important before, it does seem to be at least statistically significant in emerging economies. We also do the same exercise looking at credit default swaps. So this is our kind of measure of changes in the perceived risk of sovereign default. And what we see is that while this channel wasn't significant in previous QE episodes, so kind of 2008 financial crisis QE, we find that QE during COVID affects default risk in both advanced and emerging economies. And again, this can go either way. So you could argue that QE is kind of seen to be a sort of proactive step and the central bank taking action to kind of offset the impact of the COVID pandemic, kind of causing a sort of fall in the perceived risk of sovereign default. But also, especially kind of the narrative in some of the emerging markets we saw was that actually default risk increases, and this could be seen as either the economic outlook is worse than people perceived, or that almost QE is seen as a bailout of the government by the central bank. I will skip over these in the interest of time, but the main takeaway from this slide is that not only are these effects sort of statistically significant, but they are also economically significant in the sense that the market liquidity and credit default channels explain a significant amount of the variation in the overall term premia changes we observe. So just to kind of summarize what we've seen so far, is that while in advanced economies who did QE before the pandemic, portfolio balancing was the kind of only channel and kind of only game in town, In emerging economies in the pandemic, we see that there are these other channels that are also very important. So signaling, market liquidity, and government default risk channels are all a lot more important than we previously thought. And crucially, the regression analysis suggests that these previously neglected channels can either kind of reinforce each other or negate each other's impacts. And so if all these channels align, it can explain why a small scheme would have a very large impact on financial markets, or why it could perhaps backfire. And so these additional channels can help explain the large variation we observe, and perhaps are a more plausible explanation for the results than a pure kind of portfolio balance channel alone. And so it kind of really forwards our understanding of how this unconventional monetary policy works. Just a quick word on the limitations. I do stress in the paper that these are stylized facts because there are a couple of limitations to the empirics, which I'm currently working to kind of strengthen and go round. So the key limitations are, I suppose, threefold. So the first critique is that it is hard with an event study to fully control or measure how surprised markets are by an announcement. So being critical, one could argue, so I argue that the larger falls in sovereign bond yields observed in emerging markets are due to these additional channels. But some of this could also be driven by the fact that these announcements were just more of a surprise in emerging markets than perhaps in an advanced economy like Australia, which was near the zero lower bound. While we don't have Bloomberg coverage for either of these, it's impossible to kind of fully control for this surprise element. And so this is kind of a limit to the empirics. I also have some concerns is strong, but some kind of thoughts on the comparability of announcements across countries. So even within the kind of buckets I presented earlier, for example, countries announce their initial QE schemes in very different ways. So some countries are very specific about the amount of bonds they will purchase and for how long, and others are not. And so you could argue that if these announcements are not exactly the same, perhaps it's not entirely surprising that we see some variation in the financial market impact of these announcements. And finally, we can't analyze persistence. So by the nature of an event study, we naturally focus on the 1, 2, and 3 day kind of the immediate impact of a central bank announcement. Whereas what it would be nice to have some comment on is kind of, do these impacts persist over time? So 1 month, 3 months, 6 months down the line in financial markets. To get around these issues, we need shocks which are comparable across countries and exogenous to market participants' information sets. So shocks that are kind of equally surprising and of equal size in different countries. And the sort of way to get at these shocks is, I propose, using a market-based identification strategy. So this is building on the kind of seminal work by Gerken, Yaksak, and Swanson. And in particular, I'll be using the methodology put forward by Jarosinski and Swanson, both in 2021. The way this works is you have a kind of long time series of central bank announcements and the corresponding changes in financial market assets. And you can decompose these into rate shocks, forward guidance shocks, and QE shocks. These QE shocks are comparable across countries, and because they're exogenous, you can use them to assess persistence using local projections or estimate elasticities for structural models. So that's kind of what I'm working on at the moment, with the aim being to keep the event study and then kind of use these as a robustness check. That all being said, in the paper as it stands at the moment, I then use these stylized facts to kind of set up a theoretical model and think about how QE's wider economic effects vary with these channels. So this is the first model of QE that explicitly includes a government default risk and market liquidity channel and thinks about the impact of these additional channels on the term premia. The model setup is a kind of standard New Keynesian model with 3 key departures. So the first departure is that the government issues both long and short maturity bonds. So the short maturity bonds are a 1-period bond and the long are a kind of perpetuity. And the central bank then conducts policy using either the policy rate, so the rate on the short-term bonds, or by engaging in QE, so by varying the share of the long-term bond issuance held by the central bank. The firms in the economy are standard. And then the final departure is households have hold, again, both short and long-term bonds, but their budget constraint includes a portfolio adjustment cost, which is quadratically increasing in the deviations of the ratio of long-term to short-term bond holdings from the kind of desired steady state level. These assumptions generate the following key equations. So the first equation is that the Euler equation is negatively dependent on the weighted average of the interest rates that prevail on short and long-term bonds in the economy, where the weights are determined by basically the share of each asset in the portfolio holding. So for example, if you hold a larger share of long-term bonds, then the interest rate on a long-term bond will have more of an impact on the output gap. And crucially, equation number two, so this is the crucial one, because we've assumed portfolio adjustment costs, this gives us imperfect asset substitutability between long and short-term assets, and means that we're able to generate a kind of term premium in the model, so a difference kind of between long and short-term rates. Crucially, this model then gives us that the term premium is decreasing in the amount of QE, and the strength of QE's impact on the term premium is determined by these elasticities. So how much long-term bond yields are affected by the portfolio balance, default risk, and market liquidity channels, respectively. What I do here is I calibrate the model to the UK and Colombia. So Colombia is a really good example of an economy with a really strong default risk and market liquidity channel that kind of works together to give you a large fall in yields despite a small purchase amount. And the UK, which doesn't have a strong default risk or market liquidity channel and is kind of a good representation of how we previously thought QE worked. And what I do in the model is kind of assess whether with these additional channels, we can explain that stylized fact that, you know, a small scheme can give you more bang for your buck. A final note on the model, we then look at the kind of the policy, we look at the impact on the wider economy when the policymaker is using QE and the short-term interest rate optimally and choosing under discretion. I analyze a number of loss functions. The baseline is a loss function which is a quadratic approximation to the household utility function. But we also consider an augmented loss function, which penalizes not only QE holdings, but also deviations in the short-term policy rate and QE holdings. So almost captures a policymaker's desire for gradualism. And we minimize, and the policymaker minimizes the loss function subject to the Euler equation, the Phillips curve, and a zero lower bound on short-term rates, plus constraints that QE can't be negative or exceed a certain threshold. I then use the model to analyze the initial demand shock caused by COVID-19. So when the pandemic initially occurred and when these policies were announced, inflation was kind of fell below zero and we had a negative output gap. And what we find is that the model with these additional channels is able to both quantitatively and qualitatively match the kind of stylized facts I presented earlier. So if we compare the UK and Colombia, turning to panel E, we see that Colombia purchases a smaller amount of its outstanding bond stock, so purchases about 7% compared to the UK's 22% of the outstanding stock. And yet, because of the strength of these channels, the longer-term bond yield falls more in Colombia than the UK. And these estimates are qualitatively a very close and quantitatively a very close match for the estimates I presented earlier. We then find that kind of assuming that transmission to the wider economy is the same, QE basically has greater countercyclical effects when these channels are stronger. So because longer-term bond yields fall by more, the initial deflation and negative output gap caused by the pandemic resolve more quickly, so the demand shock dissipates more quickly, and then QE is also unwound sooner because it's no longer needed. So I guess the argument is that QE has greater countercyclical effects and sort of packs a larger punch when these channels are stronger and work together. As a bit of a health warning here, the model is comparatively simplistic in terms of its depiction of the wider economy. So we don't vary the share of constrained households or the exposure to the exchange rate. And this is something that I'm kind of planning to augment once I have the kind of exogenous shocks to back up the appearance. I also look at the loss function, which reflects a desire for gradualism. So this is kind of where at least Harrison 2017 argues this is more reflective, at least how the Bank of England thinks about using QE and the interest rates sort of alongside each other. And what we find here is that the model is still a good qualitative and quantitative fit for the data. The only key difference is that QE is unwound more gradually, or kind of more slowly, reflecting the policymaker's desire for gradualism. So again, QE doesn't work in the same way everywhere. And then when these channels are stronger, QE packs more punch as a countercyclical policy against demand shocks. So, kind of conclusions thus far. So far, it seems that quantitative easing does not work in the same way everywhere. Smaller schemes can have a much larger impact than larger purchases made in advanced economies. And a very similar announcement that a central bank will purchase the same asset type has very different impacts depending on which economy you're in. And I argue that these differences can be explained by differences in the channels of transmission through which QE acts. In particular, market liquidity and signaling channels are much larger in emerging markets, and the default risk channel is much larger than in previous QE episodes. And I argue that these channels can either kind of work together and reinforce each other's effects or kind of cancel each other out. And therefore, variations in these channels can explain variations in the overall impacts observed. And finally, using a structural model, I argue that when these channels are larger, QE has a stronger countercyclical effect. So that's it from me. Thank you very much. And I'm happy to take any questions.